You know, every so often, a single idea comes along that just changes, well, everything. And back in 2017, a paper with a super simple title was published that didn't just nudge AI forward, it totally redefined what was even possible. Okay, let's dive into this. We're breaking down Attention is All You Need, the paper that really kicked off the AI revolution we're all living in today.
So to really get why this paper was such a huge deal, you gotta rewind a bit to what the world of AI looked like back then. Honestly, progress was starting to stall out, especially when it came to understanding language. The models were getting bigger, sure, but they weren't getting fundamentally smarter. They were hitting a wall.
And this was the big question hanging over everyone's head. The best models out there processed language one word at a time, sequentially. And that made it incredibly hard for them to remember the connection between the first word of a long paragraph and the last one. So the whole field was asking, how do we break this bottleneck? How do we build an AI that actually gets context?
And then this paper dropped. A team from Google proposed something that, at the time, sounded completely nuts. They basically said, let's throw out the old rulebook, get rid of that one word at a time stuff. Instead, they built a whole new architecture on one single powerful idea: attention.
All right, so to really appreciate what a seismic shift this was, we first need to understand the problem they were up against. Let's dig into this sequential bottleneck and see exactly why the old models were so stuck in the mud.
This right here shows you the whole story, the old way versus the new way. On the left, you've got the old guard, recurrent neural networks, or RNNs. They process language like we read, one word, then the next, then the next. The transformer on the right, totally different. It sees the entire sentence all at once. Total game changer.
And yeah, that one word at a time thing, it caused some major headaches. Training these things was painfully slow, because you couldn't process different parts of a sentence at the same time. And information would get lost over long sentences. It was like a bad game of telephone. Connecting a word at the beginning of a paragraph to one at the end? Yeah, good luck.
So how did they fix this? How did they let a model see everything at once, but still understand how all the words related to each other? Well, it all came down to this one kind of beautiful idea: self-attention.
Here's the magic trick. As the model is looking at a single word, self-attention lets it look at every other word in the sentence at the exact same time and figure out how relevant each one is. So it's not just seeing a string of words, it's instantly seeing this complex web of connections between them.
The way it actually works is it's so clever. We can use an analogy. For any single word, it creates a query. That's like the word asking a question. For me, the word it, what other words in this sentence are the most important for understanding what I mean? Then it looks at all the other words, which each have a key, kind of like a label. It finds the keys that best match its query. And finally, it pulls the values, the real substance, from those important words to build a new, super context-aware understanding of the word it.
And this is what it looks like under the hood. The basic building block is that thing on the left, but the real power move is on the right. Multi-head attention. See, the model doesn't just ask one question at a time. It runs a bunch of these attention mechanisms in parallel, like 8 of them at once. One head might be focused on grammar, while another is trying to figure out who did what to whom. It's like having a whole team of specialists analyzing the sentence all at the same time.
Okay, so you've got these incredible attention blocks. Now what? How do you actually assemble them into the machine that gives the transformer its power? Well, you stack them up, layer after layer.
And here it is, the diagram that basically launched 1,000 startups. I know, it looks a little intimidating, but trust me, we can break it down into 2 main parts, the left side and the right side.
First up, the left side. That's the encoder. Its only job is to read the input sentence, let's say a sentence in English, and use all that fancy multi-head attention to just understand it, to build this rich, deep understanding of what it actually means.
Then you've got the right side, the decoder. It takes that powerful understanding from the encoder and starts to generate the output. For example, the same sentence translated into German. And as it's writing each new word, it's paying attention to what the original sentence meant and to the words it's already written.
Okay, but wait a second. If the model sees all the words at once, how does it know the order? The dog chased the cat is totally different from the cat chased the dog, right? This is solved with a really clever trick called positional encoding. Before anything else happens, it adds a little piece of math to each word. Think of it like a timestamp that tells the model exactly where that word was in the original sentence. Problem solved. So you have this wild new architecture. It's built on this radical idea. It's elegant, it's parallelizable, but did it actually work? Oh yeah,
It really worked.
This table from the paper tells the whole story. The blue score is just a way to grade translation quality. And the transformer didn't just beat the old record holder, it completely blew it out of the water. Now look at the training cost. It got this new record while being nearly 10 times more efficient to train. Better and cheaper.
That final score was 28.4. Now, a jump of over 2 blue points might not sound like a lot, but in the world of machine translation research, that is a massive, massive leap. This wasn't just a small step forward, it was a total breakthrough. And this chart really just drives that efficiency point home. The transformer wasn't just more accurate, it was dramatically cheaper and faster to get there. It's that combination, better results for less work, that made the entire AI world stop and pay very, very close attention.
The results were stunning, for sure. But the paper's true legacy isn't just a new high score on a spreadsheet. It's everything that happened next.
This architecture became the blueprint. The T in GPT literally stands for transformer. It's the engine inside ChatGPT, Gemini, Claude, pretty much every major AI tool you've ever heard of. It made large language models possible and basically unlocked the entire era of generative AI we're in now.
And what's just incredible is that the authors basically saw this coming. It's right there in the paper's conclusion. They wrote about how excited they were to apply these same ideas beyond just text to things like images and audio and video. They were literally laying out the roadmap for the next 7 years of AI research, and they were dead on.
So here we are, this one paper built on this one core idea, that maybe attention really is all you need, completely reshaped our world. It all just makes you wonder, right? What's the next deceptively simple idea that's out there right now, just waiting to change everything all over again?